Okay, so here we're going to do, this is 11.4. This is video number 2. And this is equations of planes. Okay, the first thing you're going to want to do with equations of planes is you're going to want to make sure you draw a picture to help visualize. Okay, because that's going to give you tools. In the future, when they get complicated, the picture is going to help you. Now, you're going to always draw the same one. So I'm going to put always draw a picture. Okay, so I always draw this. It looks like a plane. So I always draw a picture. 2, you're going to want to write this structure. Okay, so this structure, you're going to write A equals, vector B equals, vector C equals, and vector N equals. You're going to also write the formula. So step 3, you're going to do the formula. Okay, and the formula is R dot N equals A dot N. And then I have to tell you what N is. Somebody left. I don't know if they left because we thought it was going to be over and then they left. No, the person who left came back. Okay, good. Okay, so this is your structure on every single equation of the plane. Now, at the beginning, the first couple questions, 21 through 24, they're very straightforward. You could go right to 3, but I'm going to suggest you do not go straight for 3. I require on my test, I know we're not having tests, but 1, 2, and 3. I require 1, 2, and 3 on every single one of my problems because when the plane questions get more difficult, if I don't practice the structure, I have nothing behind me. I have nothing underneath me to support me, and I just fall. Okay, so now let me tell you about N. So N's very cool. N is, vector N is called the normal vector. And it's funny because they give this name. Like, I don't know if you remember the word regular polygon. Regular polygon meant every side and every angle is equal. It's like, what's regular about that? Nothing. Anyway, so normal vector. A normal vector, it's like the word normal. But the word normal in math is like perpendicular. And what's the other word for perpendicular? Anyone remember? The other word for perpendicular. Oh, let me go to chat in case you guys are typing. Yes, orthogonal. Perfect. Okay, so in class, I put this vector. Okay, so imagine this vector is a little post-it, and then you stick a pen right through the middle. Okay, so it's like a vector on a stick. Okay, so imagine you put a vector on a stick here. Okay, so you put the pencil through it. Okay, so this vector right here, the stick, is called the N vector. Okay, so the N vector is the stick that goes through the vector. It holds the plane up because that's supposed to be a plane. Infinite directions, like infinitely wide and narrow directions. So that's called the normal vector. Okay, now the way the structure is related is, put a line here and a line here. After I taught it for a few years, I realized if I put the lines here, it helps. Okay, A is the same thing it was with lines. Okay, so A is, we'll call it OP. Okay, which is the position vector. Now this is any point on plane. Okay, so any point on the plane, but you write it as a, so we'll put P here. So P's here. So any point on the plane. Okay, so it's the same thing as the A in the lines. It's any point on the line. But for us, it's any point on the plane. But I have to have it as a vector, so I fake it and I just write the vector brackets instead, which technically is OP. Called the position vector, but I've probably not called that in our textbook. Because they don't do it this way. They do it a different way, but the other way does not work well when the problems get complicated. There's no structure, there's nothing you can do, and like everybody misses the question. Okay, B and C. Now, B and C are interchangeable. B and C are both. They are vectors in the plane or parallel to the plane. Okay, so they're vectors in the plane or they're vectors parallel to the plane. Okay, so B might be up here in the air. Okay, and C might be a vector that's in the plane over here. Now, B and C can both be in the plane, or B and C can both be above the plane or below the plane, but parallel. And what did we say the N vector was? Oops. Oh, that's funny. You guys, it's kind of cool. Every time I hit the attendance button, it records the attendance. So it's very cool. So like the attendance is running, running, running. And then when I click the attendance button, it takes me to a Google sheet that says meet attendance and it gives me the time. So that means like your teacher, if they wanted to require attendance, which I don't think any of our teachers are going to require it, but I don't know if they're going to give you any points for, coming. It's kind of hard because during this coronavirus time, I mean, some people can't meet at the times. You might be helping your brother and sister. Yeah, I mean, you don't want to say like, oh, well, I'm sleeping. Well, then you could make it, right? If you just set your alarm and woke up. And don't lie, please don't lie to the teachers and stuff. You say you can't make it, that's okay. Okay, but anyway, it's very interesting. I can keep clicking on the attendance and it keeps making more columns in my Google Meet, my Google Meet thing. Okay, and then I'm going to share that with all your teachers so they can see if you came or not. It doesn't matter, but it'll make them feel good. Like if they see your name, like, oh, the person's coming and learning and they might be happy. Okay, so N is normal. Well, I won't put normal. I'm going to put perpendicular, right? So perpendicular to the plane. Okay, now look at my formula, though. You guys, look at my formula. What's my formula missing? In my ABCN structure. So my first question is, what does the formula not have? Okay, that's the other question. So the other question is, what does the formula have that my structure doesn't have, which is R? But we know what R is. Remember, R was XYZ. Okay, so I'll write this above with the I'll write that above here just to remind ourselves. So R is XYZ. We'll put remember. Okay. T, true, doesn't have a T. There's no T in it. But look at my structure. What letters are in my structure, in my list? So look at all the letters in your structure. Do you see how it says A, B, C, N? Yeah, B and C. So B and C aren't there. So why would we even care about B and C? Well, usually they give us B and C, or we can find B and C. Now, in the first couple of questions, they give you A and they give you N. So if they give you A and they give you N, you could kind of dive right into the formula. R dot N equals A dot N, because we know R, that's XYZ. We know N. Yes, vector R is always equal to XYZ. It's any point on the plane or any point on the line written as a vector. So it's like the point XYZ, the generic point. Like y equals mx plus b, xy is a generic point. Okay, so this is the generic point as XYZ, but we have to write it as a vector or we can't include vector operations. Like I can't do the dot product of a point and a vector. So that's why we write it as a vector. Okay, so if you have A and N, you can use the formula 3 directly. Okay, but we want to draw the picture, just draw the sketch, put the ABCN so you could force it into your brain because you're not going to have that many questions to practice. Okay, so and then you do want to stick it because what if you decide not to take HL, which is fine, and you decide to take AB next year, which of course you will, like everybody hopefully has signed up to take AB, and then you take BC. Then they do a little bit of vectors, but not these vectors. And then you might see it in multivariable calculus in college where you would see this topic and it'd be nice to have seen it ahead of time and you can kind of look through your notes. And then they might use a different formula, but you can still use your formula and attack it with the structure and just get it okayed by your teacher and say, hey, this is how I learned it in high school. Is the IB way, is that allowed? And they'll probably say yes if you go in and you ask during office hours. Okay, but this way is the way that I can get every single problem right. And I could not get every single problem right in college, which was annoying because I was a good math student. And, it's annoying when it's like magic happens and then there's the answer. And it's like, well, but what's the structure? Like, what's the structure behind it? Okay, so let me show you one. Okay, so let me show you one. I'm going to show you a more generalized one. So this is going to be example 1. I'm going to show you a more common one, and then example 2 is actually going to be an easier one. Okay, so if you make a plane, it's 3 points. Okay, so here, let me leave a little space so we can name them. And sometimes they don't name them in the textbook. They'll just write 3 points. So they give you 3 points. So they give you 2, 1, 7. They give you 3, negative 2, 9. And they give you, let's say, 2, 0, 10. Okay, so you have 3 points. And they say, write the equation of the plane containing these 3 points. So the very first thing I do is I draw a picture. One of my students one year, like 10 years ago, she would draw the picture after, and she's like, oh, show me how to draw the picture. I'm like, no, the picture's trying to help you solve the problem so that the complicated ones, that you have a chance. Okay, now the first thing, I do not call the points ABC, because then I might mistakenly think that the ABC structure are the points, which I do not want to do. Okay, so I'm not going to call them ABC, and actually I try to change the name if they're called ABC because it confuses me. Okay, so you write that, and then you just write P, Q, and R on the plane. Don't write the coordinates. So that's the picture. You're done. Okay, so your plane always looks the same. Okay, your plane always looks the same. And then you write your structure next to it. Okay, so you write A, B, C, N. And then in the last few years, drawing these lines has helped people remember that B and C are really the same. Not the same answer, but they're the same. They have the same job. Okay, so A, and let's not write the actual coordinates, but let's just write the plan. Okay, so what's the plan for A? So what was A again? So tell me what A is. Anybody? What's A? OP, exactly. Oh, you guys are awesome. So OP, that's OP. Now, what's B? Yes, Esther, the position vector. Yes. Yeah, OP, the position vector. Yes, and it's A is any point on the plane, but you pick one. So it's not the XYZ any point, it's the any point of your choice. So you could have called it OQ, you could have called it OR. We just generally do OP just so we all kind of have the same, structure down the answers. Okay. Now, what do you think B? Any ideas for B? I need a vector in the plane or parallel to the plane. I feel like I can make a vector in the plane because there's no points like floating above parallel to the plane. Anybody have an idea of what B could be? Yes, I agree. So I'm going to make B PQ. Okay, and then I'm going to make C PR. So just so we kind of have all the same answer, but those don't have to be the ones you pick. Those are just the standard ones that if you're trying to look at your answer and somebody else's answer, that, if you wanted to check the work later on when you're doing the problems, that's the standard way. But you could do QR, you could do RP, you could do any of the orders. Exactly. So PQ and PR are the ones that I use, and I usually do PQ first, just because PQ, like they're next to each other, and then I do PR. But you could also do QR if you wanted. Okay, now, so I have vector PQ and I have vector PR. How do I find N? How do I find N? Now, what's N's job? This is N, right? What's N? That's so awesome. Yes. Oh, I love how you use the X on the keyboard. Of course, if it was a dot, yes, yes. You guys are so awesome. That's why it was so exciting to do those other problems. That's why you had to watch the cross product thing first. Okay, so that right there is N, and it's always B cross C. So instead of calling it PQPR, which is completely correct, I just call it the generic name, B cross C. Okay, and then go up to this one. Can you go up to the formula where it says perpendicular to the plane and put B cross C? Okay, so I just wrote this up here. Now, sometimes they'll give you n directly. They're like, here is the vector perpendicular to the plane. And you're like, look, you gave me this stick. You gave me this beautiful gift, and I'll just use it. And I don't need B and C to find it. But often B and C find you n. But if they gave you A and they gave you n, then there's no need for B and C. Okay, so then you write the formula. Now, I always write the formula on the right side, like over here. Okay, I write the formula over here, but it's a very bad idea. So we're not going to write the formula there. I'm going to realize it always messes me up. So I'm going to write the formula underneath the plane. Okay, and then I'll show you why in a minute. So r dot n equals a dot n. So you're going to write the formula out. Okay, and we're ready. We're going to fill it in. So r, what's r? Anybody remember what r was? Yep. So r is xyz. Okay, and then n in our case, oh, we haven't found it. A, what's A? A is, oh, I haven't found it. I haven't found anything yet. Okay, and then N, I haven't found. But do you see, if you look at this, do you see why I always blow it and write the formula on the right, and then I run out of horizontal space? Now, I don't know most of you in class, so I think that it's possible that some of you are those little writers where you make like 3 columns or 2 columns or 4 columns on your homework paper. Let me tell you, that's not going to work for these planes. Okay, so me trying to write that formula over to the right always screws me up. Okay, so this is our plan. And then the dot means the dot product. Okay, so this is our plan. This is how it works every single time. I'm going to change colors to red for our specific problem. So OP. So OP is the 0.217. That's from the origin to the point. Basically, it's a point, and you just write it like a vector so that you can shove it into the formula. PQ. So PQ is a vector. It's the vector from P to Q. So from P to Q, you can subtract backwards if you want, but the way I think of it is as an action. So 2 to 3 is 1. And from 1 to -2 is -3. And from 7 to 9 is 2. PR, a PR, I need to get myself from P over to R. Okay, so I need to go this way. And again, I think the same way. So how am I going to, I subtract backwards if I can't do it forwards, but I like to do it forwards. So 2 to 2 is 0, 1 to 0 is -1, 7 to 10 is 3. Okay, and then the cross product, you're going to do the cross product of the B and the C. So maybe that's a good thing to do over here on the physical space on the right. Because if you can get your brain to always do it in the same location, it helps you remember the steps. Okay, so 1, -3, 2. We're doing the cross product, and remember the cross product is the determinant. Okay, so this is I times minus J times plus K times. I think this is like my best plane problem ever as for organization of where I'm putting everything, because I usually put the formula in a bad spot. But I think this is going to work really well on the papers. The book uses a different formula. I do not suggest using the formula in the book. It's what made it so I could not do these vector problems in college. Okay, so remember what we did here? We put a line through those columns, and then we did down minus up. We did a 2D determinant. So that would be down is -9, you're multiplying, minus up, so minus -2. J, I'm going to erase that and this. Put a line through that. We're going to go down minus up. Okay, so down minus up. So that would be what? That would be 3 minus 0. My personal careless mistake is multiplying 0 by 2 and getting 2 and not 0. So I caught my careless mistake there that I usually make. Okay, but usually I don't catch that. Oops. And then later I'm like, oh, wait. And then my students are so helpful and they tell me, hey, Miss Nichols, you made a mistake. Okay, do that one. And then I go down minus up. So down is -1 minus up 0. Okay, and then I get the vector, what's this? This is minus minus, so that would be what, -7i, but I'm going to check it later. So usually I'm okay going fast at this point. So -7i. I could just put it as a vector right now. right? So -7, comma, -3, comma, -1, a component form vector. How do I check? How do I check that that really is perpendicular to B and C like I wanted it to be? Mostly because I probably made an error. Anyone remember, how do I check that this really is my n vector? Yes, I do the dot product. So I dot product it. I don't usually write that out. So I wish I could point to you for you, but I'll highlight. I multiply 1 times -7, -7. And then I keep that in my head, -7. And then I do -3 times -3. Okay, that's 9. So -3 plus 9, that's 2. 2 plus -2 is 0. Okay, I'm good. And then I doubt myself. What if? So then I do the same thing, but with the vector PR. So 0 times -7, 0. -1 times -3, 3. And then 3, positive 3. And then this is -3. And that would also be 0. Okay, so my n's good. Okay, and then the n, exactly, dot products, you guys are awesome. And then it also helps for you to be checking it because you're reminding yourself it is perpendicular, it is perpendicular, it is perpendicular. And then in your brain, n is perpendicular. And then you also remember, how do I get a perpendicular? Oh, I use the cross product. Okay, so it helps you to practice by writing those things out. Okay, okay, so now from here, okay, once you have the plan, the operations itself are going to be straightforward. You're going to be pretty good at that. And, make careless mistakes like everybody makes. So I'm filling in my A. My N occurs twice in this formula. I'm not deriving the formula. I kind of show sometimes how it works in HL math, but mostly we don't derive it. I mean, to derive the area of a circle formula that you learned like in the 4th grade, you need BC calculus to derive it. We derive it in HL. So area equals pi r squared. So, I mean, imagine this. You just learned this now. So is it possible to derive right now? We could. It actually has to do with subtraction, like r minus a dotted with n if you subtract and factor out, and then the dot product is 0 if you move the an to the other side. But anyway, it's just like a little teaser if you want to look that up. Okay, but let me show you how to actually do the problems, which is all we're worried about. Oh, I could change those colors. Oh, I'm gonna have this color be dark green. Oh, dark green's my favorite color. Oh, that's way better. Oh, let's make this one be orange. Well, let's keep light green because I'm doing cross products. Okay, so for this one, I do the dot product. So how do you do the dot product? You multiply these two, right? So you multiply those two, and then you multiply these two, and then you multiply these two, and then we add them, right? So multiply -7 times x, -7x, multiply -3 and y, multiply -1 and z. And then over here, I multiply same thing, right? So I multiply the 2 and the -7, -14, plus, because it's dot product, 1 and -3, that's plus -3. And then 7 to -1, that's plus -7. So on this side, I get -24. And on this side, I get -7x minus 3y minus 1z. And this is the equation of the plane. Does your equation of a plane have a t in it? No, so it's not parametric. Does your equation have a vector in it? No, so it's not a vector. Your equation only has x, y, z in it. So if it only has x, y, z in it, it's called Cartesian equation. Now, we had another Cartesian equation. Okay, we had another Cartesian equation, but that one was a line. This one's not a line. This one's a plane. So this is Cartesian equation of a plane. Not symmetric Cartesian of a 3D line. Sometimes people get those confused on the test, but you don't have to take a test, so it's kind of nice. You get to learn cool stuff without taking a test. Okay, now, you can check one more thing, which I would do if I was taking a test, which is those 3 points, P, Q, and R, are supposed to be on the plane. So P, Q, and R, oh, I should keep it up higher. Oh, where I'm writing, oh, that's just because it was too hot. Okay, so you guys will be able to turn off your microphone. Okay, because I couldn't see the Cartesian equation of the line thing. So, do you see that equation of the plane? How can I check if P is on that plane? It's supposed to be, I drew it, P, Q, and R are supposed to be on that plane. So how could I check? And we're going to put could check because you wouldn't really check usually. I check if it's a test. I don't check if it's homework. So how could you check? How do I check if P is on plane? And then I want to check if Q is on the plane. And then I want to check if Q is on plane. And then how do I want to check if R is on the plane? Anyone have an idea? Yes. Plug in values and see if the equation is true. Right? So if you substitute, just like you would to find out if a point is on a line, to find out if a point is on a plane, you can substitute. Okay. So that would be, oh, let me color code. How fun. So -7 minus 3 minus 1 equals -24. So I'm going to put a question mark because we don't know if it's true. And then I'll do the same thing. -7 minus 3 minus 1 equals -24. And then I'm just going to put etc. So I didn't really do it with R. And usually I just check it in my head. I don't write it out. Okay, so what was P? P was 2, 1, 7. And then Q is 3, -2, 9. And then R, I could probably do it in my head after I do it. So I check them. So -14 minus 3 minus 7 is -24. And this is when I math pray. Please be -24. If it's not -24, I made a mistake. It's -24. Cool. So that means point P is on the plane. Now, what about this one? -21 plus 6 minus 9. Is that -24? -3, -3 plus, right? This is -3 plus -21. This is a yes too. Cool. Now, is R on the plane? Let me check. So what was R? R was, let's see what point R was. R was 2, 0, 10. Let me just memorize that. So 2, 0, 10. So, because I want you guys to see this in case I'm going too fast. So 2, 0, 10, 2. 2 would be times -7. That's -14. 0 is 0. And then minus 10. So -14 minus 10 is -24. So I'm going to put yes over here. So that means I did it right. My 3 points are on the plane. They just fell off my desk. Yeah, that's true. But I could have made a mistake when I was doing it, which is totally possible. But that would be if I definitely would check. I think if you checked R, you could check backwards. It's kind of nice. Now, are there more points on the plane? How many points are on a plane? Infinite number of points on the plane. So can you look at the equation of the plane and find another point? Anybody look at the plane? So just stare at the plane and think, is there another point on that plane? Is there another point on the plane? And give me the point. Give me a point on the plane. 30. Pretend extra credit points. You can give me a point on the plane that's not one of the original 3. And in the meantime, I'm going to quickly look at the homework. And then I know there's 2 more examples I want to show you. 080. I would say yes, Max, for your 30 pretend extra credit point. PEC 0024. Yes, Richard, you're right. Anybody else? Those are the friendly ones, huh? I think the other ones would be hard to find. We could do a fraction, right? 24/7, 0, 0. Anyway, so sometimes when you want equations, and when you want points on the plane for something else, you need it for distance from a point to a plane. But I don't know if the homework has that. So right now, I just want you to write some equations of planes. And then I would do that before you did the other part anyway. So there might be a video 3, but not today. Okay, so let me show you this one. You're going to like this one. This is like the super awesome one. So this is example 2. And this is the first couple questions they give you. They say, here's a point. So 2, 5, 3. And then they tell you it's perpendicular to, and then they give you a vector. And they say, write the equation of the plane. So how do you write the equation of the plane? Well, first thing, you draw a picture. Okay, so draw a picture, write your structure. Okay, so you want to do this every time you say, if they mention the equation of a plane. Now, if they just mention plane, you definitely need a picture, even if they want the equation of a line. Because sometimes they'll have a line, like write the equation of a line parallel to the plane or perpendicular to the plane. Okay, so write your formula out or write your structure out. And then draw what they gave you. So they gave you this point, so we'll call it P, perpendicular to N. Okay, so they gave me my stick. Did they seriously give me my stick? They said it's perpendicular to that normal, that thing. So perpendicular, and they called it N even. So they gave me P, right? OP. And they gave me N. Because there's no J, that's why J is 0. So this is not needed. So B and C are not needed. And OP is the point written as a vector, so 2, 5, 3. So I've got my structure and my picture, and then I'm going to use my formula. You're going to want to write your formula, A dot N equals R dot N. And then you're going to want to write it because it's wide. Okay, so it's wide. So A is, oh, except you guys, I wrote it backwards. I usually write it R dot N equals A dot N. Okay, good. I was thinking that looks backwards to my brain. Okay, you know, it would be the same thing, but let's be consistent. So A dot N equals R dot N equals A dot N. So R is X, Y, Z. N is -207. A is 253. And N is -207. Oh, okay, Richard, you figured it out? Yeah, just scroll back up. I know. Yeah, just scroll back up. You know what the map analysis honors teachers are thinking, which is kind of cool, is they said, hey, what are you eating, puppy? Puppy, you're not allowed to eat that. Okay, here you guys want to see my puppy? My other puppy. Okay, you guys click on me if you want to see my puppy. Here's my puppy. Here's my black puppy. You see my black puppy? This was what she was eating. Like a ice cream stick. Oh, that's so cute. She doesn't like to be held, so lucky she didn't pee on me. Did you want to say hi to the student? Let me down. I took that away from her earlier. Okay. Anyway, back to the problem. So draw the picture, write the structure, write the formula, just so you can get it in your head. You won't be practicing too many of these. And then you're going to remember them not for next year, for 2 years. Okay. And then what's kind of cool, Miss Nicholas said, is that, I was telling you that we're counting notes. So the notes that you take from this, you're going to take pictures and upload, and we're going to give you homework points for those too. So we're going to give you homework points for the notes and then homework points for the homework assignments. So that's kind of cool. And then if you don't have time to do one, then we're going to put NA in there, I think, or we're going to leave it blank. I'm not sure. It depends. We have to rediscuss that. Oh, wait. You guys, do you see an error? I have an error here. Let's see if anybody noticed it. Esther. How funny. I looked, I was like, wait, something's wrong right now. Okay, good job. That is supposed to be an equal sign. Nice. Okay. So equals, and then you multiply these, -4. I mean, those, I'm just arrowing them. Arrow makes it feel like I'm doing a vector, so I don't want to do that. So let me highlight. So 2 times -2, and then 5 times 0, and then wiggle, 3 and 7. Okay, so that would be -4 plus 0 plus 21, which is 17. -2x plus 7z equals 17. And that is the 3D. 3D, it's a plane. I mean, planes are always 3D, so you don't have to put 3D. But just so you can remember, that's 3D. And then what form is it? It's x, y's, and z's, so that's called Cartesian form. What's confusing on a test is there's two Cartesian forms. There's the Cartesian form of a plane, and then there's some symmetric / Cartesian form, but they still call that Cartesian form of a line. Cartesian form, like say standard form is 2x plus 5y equals 10. Like standard form of a line. Standard form of a line can also be Cartesian form of a line because it only has x and y, or x, y, and z. So x, y, and z is called Cartesian form. Okay, anyway. So that's kind of cool. Isn't that short? That one's beautiful. They gave you a gift. Okay, so we'll put over here. I'm going to highlight it right here, and then I'm going to write in the highlight. Okay, so this is a gift. If they give you the normal vector, they gave you a gift. Okay, so let me show you one more. I'm going to show you a complicated one. Okay, it's going to use a lot of our concepts all here together. Okay, so I'm going to show you a complicated one. This is the one that's real tricky that people miss on my quiz and my test. And this is why you're drawing the structure. Okay, so this one says let me give you, we need one more piece of information. I mean, you wrote all this. I just need to have you give me an observation. Okay, so let's go back to this front one, this example number 1. My question is, where does the normal vector live in my boxed equation? My boxed equation, where does the normal vector live? So look at the components of your normal vector and look at your equation of the plane. Where does the normal vector live? Yes, the coefficient. So the coefficients of the normal vector are the coefficients of the xyz are the normal vector. Okay, so let's just draw kind of a little arrow here. They're actually a normal vector. Okay, so they're the normal vector. Now, did you already know that, Patrick? Or did you just figure that out by observation? Or half and half? Oh, that's so cool. Okay, awesome. You know, because in class, usually you guys don't answer as much, right? Because you're being respectful to the teacher. We're trying to have you guys answer us, but sometimes you don't want to answer us. So this is really cool. Okay, good. So the coefficients. Okay, so now let's check the next one. What are the coefficients of this answer? So this answer, the coefficients, I'm still on my highlighter. The coefficients, are those the normal vector? So let's check. They are, because y is missing. Okay, so that's where now A does not show up because A got absorbed. Okay, so A got absorbed. You can't find the A, but you can find the N, and then we could guess points by trying to find points that work in the equation if you ever needed a point. Okay, so we need that for my next problem. Okay, so I'll let you guys draw that. Okay, so example 3. Let's see how it is worded here. Oh, there's 2 of them. That's kind of cool. So in the new book, I wonder if we assign these. So I'll check and so I'll give you some practice. I'm not going to tell you which one it's like, though, because I need you to figure out that it's like that and not just, do your homework like the ones that you know. So I'm not going to tell you the numbers. Okay, so you're going to have a point P. Yeah, let's have point P is 3, 7, 2. point Q is -4, 6, 0. And it says it's perpendicular to, and then -2x plus 5y minus z equals 16. So that's the problem. And it says write the equation of the plane. Now, if you guys are not live here today, if you're on the video, it would be better if you paused it and try to figure it out yourself to see where you get stuck. So remember, if you're trying to find the equation of the plane, you need a picture, okay? Because you're trying to do attack problem solving. Okay, so we don't want to have an example for every single question you have. You're doing attack problem solving, and this is your attack strategy. So I have P and Q there on the plane, and then it says perpendicular to that. Now, when I look at that, I have to decide, like, what shape is this? Because there are some problems, like question number 25. It says that you're perpendicular, and then they give you an x equals y equals z equals equation that's parametric form. Parametric form is not a parametric form is a line. So it's saying it's perpendicular to the line. And you're like, the line, and then you draw the line, and you're like, hey, the line is the normal curve. You know, or not the curve, but it's the normal. So it's kind of cool. Okay, so anyway, PQ. So PQ is perpendicular to this object. But what is that object right there that I underlined? So what object is that? Is it a line? Is it a line? What do you think? Is it a line? Plane. It's a plane. Exactly. It's a plane. Okay. So it's a plane. So it's a plane. So I need a plane to be perpendicular to a plane. Now, I used to draw it in the middle. Okay, I used to draw right here in the middle, but I found that that is not a good place to draw it. So what I'm going to suggest is you're going to draw it on the end, okay? And I'm going to draw it in red, but usually I draw it in the same color. But so make an up plane like this. Okay, so make a plane on the edge. Okay, so make a plane on the edge. And then this is perpendicular. Okay, so that's my plane. I'm going to circle it in red. Okay, so that's my plane. And you're like, great. Don't know what to do. So at the moment you pause and you're like, okay, whatever. I need my structure. So let me do my structure. So A, B, C, N. A could be OP. B could be PQ. I don't have a C. I don't have an N. Well, it doesn't make me think of an N. They kind of gave me an N. Now, how do I find an N? Now, that's actually, it's related. So I'm going to go over here to the red equation. I'm going to call it N. And I'm going to call it NG. I'm going to put a subscript of a G. G stands for given. Okay? That's the N of the given plane. So the N of the given plane, you grab off the coefficients, like you guys noticed. So you grab off the coefficients. That's the N given. Now I'm going to draw the N given over here. I'll draw it on the bottom just because I have so much writing on the top. But it's the stick. So my question about N given is N given N. It's called N. Feels like N. Is it N? Not N. Now, why is it not N? It is N. It is an N. Is it my N? Let me draw my N. Okay, let me draw my N. My N is right here. This is my n that I don't know, but I just stuck it somewhere and made it perpendicular. Yeah, I gave you a parallel plane. Yeah, that's very cool. Patrick, that's cool. Okay, so is my n NG? Yeah, so what's NG? Is NG parallel to the plane? Oh, I made too many lines here. I wasn't supposed to put a line there. Remember, B and C are in the plane or parallel to the plane. So B and C are in or parallel to the plane. So NG is parallel to my plane, my new plane. Now, if we did not draw the picture, we would never know that. And then I'm going to show you, Patrick, why you got a parallel plane, because that was a very good, cool thing. If he wanted it to be parallel to that plane, I want to draw a picture just to show the picture, and we won't do the problem, but it's very cool. Okay, so how do I find n? And then let's put a little star here, because this is the whole trick. That's the whole trick to the problem where people miss it on my test. Because they put ng as n, which is not. Okay, so my question is, how do you find n? Anyone have a how do I find n? My real n. How do I find n in example 1? Yes, cross product. Cross product of what letters? Yes, cross product of B and C. Exactly. Okay, so the cross product of B and C gives you n. Once I find that, I'm going to use r dot n equals a dot n. I'm going to put etc. This is etc. We get it. We understand it. We don't need to actually do the numbers. Okay. So I want to draw you one more picture. Okay, so cool stuff. Okay, so this is a partial example. So this is example 4. This is a half example. And this example 5 is a half example. I'd much rather do that than actually giving you example 3 finished. So example 4, they give you a plane. And they give you a point. And then they say it's perpendicular to, and it says x equals y equals z equals. Okay, so they give you point P, and they say it's perpendicular to this. So if I have point P and it's perpendicular to that, I draw the picture because the picture is the only way you're going to find the problem out. Okay, so you do A, B, C, N, and we're not going to do the whole thing. Okay, we're just going to kind of look at the structure because the structure is the thing that's going to help you in these problems. Okay, so A. A is a point on the vector. I mean on the plane. So OP. Except, sorry about the D. I don't know why I put D. You know I put D because A, B, C, D. Like, it makes sense. Okay, but that's it. Picture is how you're going to figure out the weird ones, okay? Instead of just memorizing. I mean, you don't have to know it for a test anyway, so you want to do the problem solving. You're trying to become thinkers, right? You're not supposed to just become followers here. We're trying to be thinkers. So how do we think about this? What shape is this yellow, this red thing I just circled? What shape is that? Yes, it's a line. So that's why I write 3D line every time I write this, because I need to force in my brain that's a 3D line. Because if I don't force in my brain that's a 3D line, that doesn't look like anything. It's also called parametric form because of the T. Okay, so that's a line. So if that's a line, now if any of you are in the situation, I mean, you guys are already at this video, but if you are going to take HL math, this we do review and I teach it again. The only thing is that, it's nice to have seen it before. But if you don't take HL math, and that's okay too. If you then take it in college, if you take a multivariable in college, they will do these planes. And as we found out from that wonderful student yesterday, is in aeronautical engineering, they do 3D stuff, so vectors are going to be pretty important. Okay, so anyway, so that's a 3D line. So draw the 3D line. So I have the line. It says it's perpendicular. So what's the 3D line, right? Sophia. So what's the 3D line related to? So think about that. I just have to plug in my batteries. Okay, so the 3D line, what's the 3D line look like? So 3D lines, is it BC or N? I feel like it's N. Okay, so I do feel like my 3D line is N. The only thing is I have like the parametric equation of the M. I mean the N, I mean, not the M. So the N. Anybody have an idea then about what N is? So what's N? So look at the line, coefficients before T, exactly. Oh, you guys are so awesome. Okay, you guys gotta make me feel like you knew this ahead of time though. So I'm like, oh, they just knew it ahead of time and they're just answering me. But this side stuff, it's pretty cool. Okay, so N is actually the coefficients here, right? Like the slope vector of the line. Okay, cool. Thank you. That makes me feel good. Okay, so I'm going to call this line L. Okay, and then this is line L. Handwriting L. Okay, so we'll call it line L. Okay, so line L. And then the normal vector is the coefficients of T, which is the slope vector. You guys are learning it pretty fast. Okay, so N is that. Oh, what beautiful thing did they do? That's a gift. And what gift does that mean? That means these are not needed. Yay. Okay, if they give you N, you don't need B and C. Okay, and then we'll put etc. on this one. And then let's do the one that Patrick did. This was cool. So he said, so there was a point P, and then he said his turned out to be parallel to the plane. So let's say we had parallel to the plane. Oh, well, I mean, we could do his parallel to the plane. Well, it will just make a new one. Okay, so say you had this. Okay, so we draw a picture. Here's our point P, parallel to the plane. Okay, so I'm gonna circle this. I like the color coding. I don't do this as much in class because I usually have I used to teach with a pen. So, I mean, you can't find, the last time I taught math analysis, I didn't teach with the tablet. I have been teaching in the tablet the last couple of years, but with the colors, you really can see it a lot better. And, I'm teaching in class, I have a pen. I mean, I could barely find a pen that works, let alone multiple colors at the time that I want it to be. Okay, so that's my given plane, right? So now every plane comes with a stick. Okay, so plane on a stick. So that's N. I'm going to call that N given. So that's my N given. And my N given is what? It's 2, -4, 5. It's weird because it says parallel. That's my abbreviation for parallel. What would the vector be for? Hold on. For example, what would it be for example 4? Oh, we don't know it because I didn't give you a P. They'd have to give you a P. I was just doing a half example. So yeah, so vector A would be whatever point they gave you. For B, then you would put that in as OP. So I didn't give you enough information for example 4. But if you wanted to finish it, you could make your own point. Yeah, it's just because I didn't give you enough information. Same thing on example 5. I'm not giving you P. We're just trying to analyze, think through the process, because that's really the point. We're trying to teach you how to think. Once you get to math analysis honors and above, it's all about thinking. You're going to learn formulas, you're going to learn techniques, but all the problems aren't going to match perfectly. You got to throw your math at it. Okay, especially in HL math. Okay, so NG. So NG. Now, how is NG related to my N? So here's my N in my picture. My N that I want. And then I'm going to do my ABCN structure. And then this is what Patrick accidentally did. Okay, which is good. It gave us the question. And I don't think this is any of the problems in the book, but it's the attack strategy that's going to help. So A is OP. So how does NG relate to N? How does NG relate to N? Yes, parallel. So parallel vectors are basically like equal, sort of equal vectors. Okay, so N A N A N. The normal vector, the green normal vector, is the normal vector of the plane. Okay, and that's what most people do in example 3. So in example 3, they're like, I'll just take the coefficients. The coefficients are normal. I'm looking for a normal. Let's just make N and G like I just did. Okay. But really, the N in example 3, so let me zoom out. The N in example 3 of the given plane is actually not perpendicular to my plane. It turns out to be parallel to my plane. Perpendicular to perpendicular is parallel. And then example 5, I'm saying parallel, but the yellow coefficient vector, right, or the coefficient is the normal, but the normal of that one is also the green normal. That's why you draw the pictures. And that's why I require the pictures in my class. Like I take off points if they don't draw the picture and I threaten them with pictures, but we don't have a test anyway. Okay, but the point is so that we can learn it and understand it. Okay. Cool. Nice. Well, thank you. You guys, thank you for helping me make the video. I love having you guys in class instead of me teaching by myself. So I know it takes a little bit longer. So, you know, but somebody can just watch us at 2 speed or watch us at 1.5 speed. So anyway, I really thank you guys. Okay, and then actually we're done with the chapter, I think. I'm going to check and see if there's any other questions. There might be. Line of intersection of 2 planes. Yeah, let me just give you a line of intersection of 2 planes idea just in case. I don't know if this is on the homework though. So line of intersection of 2 planes or 3 planes. I'm going to show you a 3-plane one just so you could see. Now you got planes, right? So I make up a plane. So here's a plane. Here's a nice plane. Just made up a plane. Here's another plane. It's funny because we don't think of these as planes, but these are really planes. And actually this plane is still a plane, even though it looks like a line, because I'm in 3D. So an X and a Y with no Z means Z could be anything. So it's also a plane. So how would I find the intersection of 3 planes? Intersection, I usually solve the system. How do I solve the system? Why I solve the system? Elimination substitution. But what did we do the other day instead of elimination substitution? We did augmented matrices. So I would do augmented matrices for this. And then the answer for the augmented, so I'll make another video of this if this is on your homework, but and maybe if not anyway, just so, you know, it's enrichment, so you can kind of see it. So it's kind of cool. This is 0. So I do augmented matrices, ... Oh, that'd be cool. I could just whip it out on the calculator. I might. Let me do that on the calculator. Okay, let me just do RF on the calculator. And we'll put usually by hand. Okay, but I'm just going to whip it out on the calculator so I can show you because I think it's cool. Come on, calculator. Okay, so on the calculator, I'm hitting matrix, edit. Ooh, an 8x4? Why did I have an 8x4 on there? Okay, so this is a 3x4. So 2, -3, 5, 10. 1, 2, 3, 7. 1, -3, 0, 20. Okay. And then I do RF on my calculator. So math, matrix math, RF. And then I do, oops, I hit the wrong button. Matrix. Oh, seriously. Okay, let me go again. So matrix, RF. I can show you guys. I'll show you. I know last time I made a video and you're like, but I can't see it. Okay, so let me do this. So let me go to my tablets one. I already typed it into my one. Okay, so there we go. Okay. So matrix, names. Oh, my tablet's kind of being slow. Okay, so matrix. So I go to matrix. I go to names. I go to edit. I edit this one. I want to make it a 3x4 matrix. Oops, I typed in 3x3. 3x4 matrix. I'm going to type in the numbers that I just typed in for this one, which are 2, -3, 5, 10, 1, 2, 3, 7, 1, -3, 0, 20. Okay, so I'm going to type those in, hit quit, go back to matrix, go to math, go to RF, go to RF, go to matrix. Don't hit whatever I hit to get that. Okay. Okay. Okay, so RF, matrix, A. Okay, here we go. I'm letting you guys catch up and doing it also on my phone. Matrix, names. Okay, same answer. Yeah, I'm gonna change it to fraction. So I'm gonna hit math, enter, enter. Math, enter, enter. It changes to fractions. Okay, they're pretty nasty fractions. Maybe I kind of like them as decimal. Oh, that's interesting. They don't intersect in a line. They intersect in a point. Oh, that's me. Okay, that's annoying. That's only annoying because of what I wrote the question to be. It's okay. So let me go back, get out here, type that into here. So one note. So the answer for RF, actually the 3 planes, we'll put line or point of intersection. Okay, so for this one, the answer was 1, 0, 0, 0, 1, 0, 0, 0. This should have been a 0 if it was going to be a line. Okay. So this is 395 over 16, 25 over 16, and -111 over 16. Okay, so then actually these 3 planes, the 3 planes intersect at the point 395, 16, comma 25, 16, comma -111, 16. That would be like the geometric description. Okay, and then let's just do a what if. What if there were only 2 lines? Okay, so what if, and I think if I do 2 lines, we don't have to really type it all in again. So let's do just the top 2 lines. And you can imagine doing this RF by hand, but I'm using the calculator. Okay, so what if it were 2? I would do 1, 0, 0. Oops, not 1, 0, 0. I would do 2, -3, 5, 10. Right? And I would do 1, 2, 3, 7. And then I would do RF on my calculator, but I'm pretty sure on my calculator, if I just type in edit 2x4, it's going to give me that one. So I just saved myself some time. And then I'm redoing RF of A, my new A. Okay, and then I did RF, calc, and then again, usually by hand. Okay, RF on the calculator gave me this, 1, 0, 19 sevenths, 41 sevenths, 0, 1, 1 seventh, 4 sevenths. And then this one is missing a row. So this row is missing. Okay, so this is a let z equals t problem. So let z equals t, because this is my problem row. And then you write, I'll highlight this first row becomes what I'm about to type, or what I'm about to write. So that would be x plus 19/7 t equals 41/7. And then I'll do the next one in blue. So this equation becomes this equation, which is y plus 1/7 t equals 4/7. And then you would solve for x, y, and z. So x, y, z. So x is 41/7 minus 19/7 t. And y is 4/7 minus 1/7 t. And z is t. And what shape is that? Let me go to the comment. What shape is that one? It's a line. So this is a 3D line. So what I have from above, so I'll go here. This one would be two planes intersect in a 3D line. Now you can have three planes intersect in a 3D line as well. You know your textbook or your notebook, if you hold up some of the pages, they're each planes kind of. So you could have, they intersect in the binding. Or two lines intersect in a plane could be your ceiling, right? They don't have to be perpendicular, but like your ceiling, because mine's slanted. So the ceiling and the wall, that would be two planes intersect in a line. So that would be the situation. It could be with threes or it could be with twos. So I don't know if that's in your homework because I don't have the homework calendar up right now. Anyway, so throw your math at those problems and then you see how it goes. And I wonder if you also have distance. We used to do distance, but I don't know if they took that off because I thought there was only one more homework assignment on this. So I wonder if it got deleted a couple years ago. So if so, I'll make another video just in case you guys want to see it. But I don't know why it would have been deleted. Maybe because they ran out of time and so they deleted some topics. But anyway, it's nice to see these anyway. And then what we're doing next week, or not next week, spring break, but we're doing when we get back from spring break, is we're doing equations of, not equations, we're doing limits, which will be for AB calculus. And then we're doing some other miscellaneous topics that'll help you, that are in like the appendix or random other spots. And then how to graph a calculus parabola. And then that'll be the first week, 2 weeks, I think, when we get back. And then we're going to go back and do all of these assignments from 8 to 11. So if you've already done that, you're going to be like, get credit for all those assignments. And then, you know, kind of have a happy time with math. Okay. I'm going to change this. I'm going to stop this recording. Let me stop this recording. Stop recording. Okay.